Hello everyone. Today we will be discussing the quick solutions of all India Akash Test Series JEE Main Test 7 Code A and B. So let us start with the question number 61. It says that the domain of the function fx equal to sine inverse GIF of x plus 1 by 2 plus under root of 3 into mod x minus 2 is. Now we know that domain is those values of x for which the function fx is defined, right? Now for this sine inverse GIF of x plus half to be defined, GIF of x plus half will go from minus 1 to 1, right? Now GIF of x plus half can take values minus 1, 0 or 1. That is, x plus half will go from minus 1 up till 2, right? And on minus 1 we will have equality sign. Now we can say that x will go from minus 3 by 2 to 2 minus 1 by 2, that is 3 by 2. Also here we can see that the value given inside the under root bigger than equal to 0, that is, we can say that 3 into mod x minus 2 should be greater than equal to 0. So let us say we take case 1 where x is greater than 0. For x greater than 0, mod x can be equal to x. Hence we can say that 3x minus x, that is 2x minus 2 should be greater than equal to 0. That is, x should be greater than equal to 1. So taking intersection of this and this, we can say that x should be greater than equal to 1. Also in case 2, let us assume that x is less than equal to 0. So 3 into mod x can be written as minus 3x minus x, that is minus 4x minus 2 should be greater than equal to 0. That is 4x plus 2 should be less than equal to 0. That is 2x plus 1 should be less than equal to 0. That is x should be less than equal to minus 1 by 2. Now taking intersection of this and this, we can say that x should be less than equal to minus 1 by 2. So these are the two values of x that we get from here, and we have to take intersection of 1 and 2 with 3, right? Now let us draw the number line. Let us say this is minus 3 by 2, this is 3 by 2, this is 1 and this is minus half, right? Hence 1 takes the values x greater than equal to 1, that is these ones, and x less than equal to minus half, that is these values. And in equation 3 takes the values from minus 3 by 2 to 3 by 2. Here it is closed and here it is open. Hence we can say that intersection of these two will give the values of x belonging from minus 3 by 2 to minus 1 by 2 union 1, 2, 3 by 2 open, right? So the correct answer will be option number 2. Now next is question number 62, which says that let a relation S equal to x comma y where x belongs to R, y belongs to R, such that x square plus y square minus 6x plus 8y is equal to 0. If A is equal to domain of S and B is equal to range of S, then A intersection B is. Now here the given equation can be rewritten as x minus 3 whole square plus y plus 4 whole square. Here we have added 9, so we will subtract minus 9 minus 16 equal to 0. That is x minus 3 whole square plus y plus 4 whole square is equal to 5 square, right? So from here we can say that x minus 3 will go from minus 5 to 5. Also y plus 4 will also go from minus 5 to 5. Because y plus 4 whole square is less than equal to 25, right? Hence, from here we can say that x will go from -2 to 8, and from here we can say that y will go from -9 to 1. Hence, we can say that A is equal to domain of S, that is -2 to 8, and B is equal to range of S, that is it is going from -9 to 1. So we can say that A intersection B will be equal to -2 to 1, right? So the correct answer will be option number 3. Next is question number 63, which says that the value of the expression summation I going from 1 to n, summation j going from 1 to I, summation k going from 1 to j6 is equal to. Now here, firstly let us find the value of summation k going from 1 to j6, right? Now this can be written equal to, 6 can be taken out, it is equal to summation of k going from 1 to j. Now there is no term of k here, so summation will be like, taking 6 common, we will add 1 j times, so it will be equal to 6j, right? Now next is summation I going from 1 to n, summation j going from 1 to I, 6j, right? So we have to do summation of this first. So this will be equal to summation I going from 1 to n, taking 6 common, we can write it as j is going from 1 to I, so it will be equal to 1 plus 2 plus 3 up till I. Now we know that sum of that series is equal to I into I plus 1 upon 2. So this will be equal to, taking 3 common, it will be equal to summation I going from 1 to n, I square plus I, right? Now that can further be solved as, it will be equal to 3 into, now summation of I square, where I is going from 1 to n, will be equal to n into n plus 1 into 2n plus 1 upon 6, plus summation of I will be equal to n into n plus 1 upon 2, right? Now this can further be written equal to 3 into, taking n into n plus 1 upon 2 common, we will be left with 2n plus 1 upon 3 plus 1, right? Now this will be equal to 3 by 2 into n plus 1, taking 3 common, it will be left with 2 into n plus 2, right? Now this is equal to n into n square plus 3n plus 2, right? So the correct answer is option number 4. Next is question number 64, which says that number of 7-digit numbers formed by distinct digits taken from the set 1, 2, 3 up till 9, such that the integers 2 and 3 do not appear consecutively in either order, is equal to. Now we have to find the number of 7-digit numbers, right? Now the total number of 7-digit numbers will be equal to, in 9C7 ways we select any 7-digit, and in 7 factorial ways we arrange them, right? So these are the total number of 7-digit numbers. Now as we do not want this thing to happen, so we will subtract those number of numbers in which 2 and 3 are appearing consecutively, right? Now to subtract those numbers, firstly we want to make sure that we select 2 and 3 number, right? Now we have already selected number 2 and 3, right? So from the rest 7 digits, we have to select 5 digits first, right? In 7C5 ways in 2. Now we have selected these 2 and we have 5 other digits also, right? Now we will place 2 and 3 consecutively, right? So let us assume 2, 3 to be 1 digit, right? So we have total 6 digits. Now the total number of ways of arranging them will be 6 factorial, and we want to arrange 2, 3 also. So it will be 2 factorial, right? So this will be equal to 9C7, that is 9 factorial upon 7 factorial into 2 factorial. So 7 factorial will get cancelled. So it will be equal to 2 factorial minus 7 factorial upon 5 factorial. 2 factorial will get cancelled. So it will be left with 6 factorial. So this is equal to 151,200. Right? So the correct answer will be option number 2. Next is question number 65, which says that if m comma n are any two integers and m is equal to n square minus n, then m square minus 2m is always divisible by. Now here we can see that m is equal to, taking n common, we can write n into n minus 1, right? Hence we can say that m square minus 2m can be written equal to m square, that is n square into n minus 1 whole square minus 2 into m, that is n into n minus 1. Now here we can take n into n minus 1 common. So we will be left with n square minus n minus 2, right? So making its factors, it can be written equal to n into n minus 1. One of the factors of this is minus 1. So we can write it as n plus 1 into n minus 2, right? So this can be written equal to n minus 2 into n minus 1 into n plus 1, right? That is m square minus 2m can be written equal to product of 4 consecutive integers, right? So we can say that it will always be divisible by, the minimum 4 numbers are 1, 2, 3 and 4. So we can say that it will always be divisible by 24, right? So the correct answer will be option number 1.